what they can be used for. So in today's class, we'll commence the application of machine learning. So let me share my screen briefly. Okay, I want to believe everyone is seeing my screen. All right, so let's proceed. Let me open my Google Colab first. The task we'll be doing today will be performing a development of a model for predicting shoe size of a person. If you remember in our last class, I said we have two types of supervised learning. Remember, I told you I said generally we have three types of machine learning. We have supervised, we have unsupervised, and we have reinforcement. However, I said for the scope of our course, we'll be looking at supervised machine learning, and I said that supervised machine learning is divided into two, which I called regression and classification. And if you recall, I differentiated what regression is from classification. I said regression is a type of supervised machine learning that focuses on developing models that can predict continuous values. What do I say? What do I say? Continuous values. I said continuous values are values that they can change. They are not static, in the sense that the value I may have might differ from the value you have, and the value you have might differ from the value that another person will have. That's what we call continuous values. And then I said the second one, which is classification. I said classification has to do with prediction of discrete values. And what do I say discrete values were? I said discrete values are values that they can either belong to group A or group B, or they can belong to class A or class B or class C. Plenty people can have the same value. Those type of supervised machine learning is what we call classification. So those were the things we looked at last week. I also showed you how you can import some of the libraries for regression and for classification. So today we'll be looking at a practical application of regression, how you can build a machine learning model that can perform regression. Now, if you recall in our last class, I mentioned some basic steps for developing a machine learning model. I said if you are trying to build a machine learning model, the very first step you have to do is to import your library. Now, if you remember back to our previous last two classes, where I taught you data exploration, the very first step I spoke about is also importation of data and the libraries you will use. So that's one thing about machine learning. And I'm hearing myself in the background. I don't know. I see someone turned his mic on and I'm hearing myself. Okay, stop.
One minute. I was over 500,000. Both for us back end.
Okay, so let's proceed. So as I was saying, I said if you remember in our last two or three classes, where I taught you data exploration, I said the very first step is importation of libraries and importation of your data. The same thing applies. Now, all what we've been doing in the past are a build up to machine learning. So we'll have to start all those steps again before we come to model development. So that is how the pattern is. Whenever you're trying to build a machine learning model, it's the same sequence you have to follow. So that was why you see I opened this file for day 4. That was a file we did for some days back in my Google Colab. I just opened it because it's on this file we are going to build. So the very first thing is to import the libraries we are going to use. Now, the very first library we import is our pandas. What do you say pandas is used? Pandas is used to open your data. It allows you to open your data. It allows you to clean your data and to do all sort of things. The second thing is your NumPy. NumPy allow you to perform manipulation on numbers. I told you that. And today we'll be doing some additions to our models. Now today we'll be importing some other libraries, such as one of the library I want us to import. We are going to try and build a linear model. So in order for us to build a linear model, we need to import that linear model. And all linear model are in sklearn.linear model class. So the linear model we are going to import will be, sorry, a minute. The linear model we are going to import, since it's a regression task we are doing, is going to be linear regression. Sorry, linear regression model. And another thing we need to import is a label encoder. Dot preprocessing import label encoder. Label encoder, I've already used it, so that's why I just imported. We've used it in our last class where I taught you can convert categorical data to numeric data. So we are going to import these two libraries in addition to the other two that we've imported. And another thing we'll import today is another thing we'll be importing today is train test split. I'm going to explain that. And then one more thing we import again is sorry, made a mistake here, supposed to be from sklearn.metrics import okay, let our Google Colab connect first, then I'll explain what all these things are. Okay, it's connected. Now, remember that day I spoke about I'm coming. Okay. All right, all our libraries have imported. Now, if you remember the other day I talked about in the linear models, I said we have two classes. Some are used for classification, some are used for regression. And for the classification, I said for the regression, I said one of the model you can use for regression, which is a linear regression model, is the linear regression. I said if you are doing classification, we call it logistic regression. So in classification, I'm not going to say from sklearn.linear model import linear model. If I'm doing a classification task, I will say from sklearn.linear model import logistic regression. But since it's a regression task we are doing, we'll say from sklearn.linear model import linear regression. So this algorithm is what we use for building our machine learning model. Now, the second line from sklearn.preprocessing import label encoder. This one, what is his own work? His own work is to convert categorical data to numerical data. Now, if you recall again in our last class, I spoke about splitting data into training and testing. Splitting data into training and testing. Now, in order for you to split your data and give a particular portion for training, another portion for testing, this is what we use. We use this train test split. And you always get it from this sklearn.model selection. This is the library that allows you to import this train split, because you will need to split your data into training and testing. Remember I said we have two types of splits. You first of all split into dependent and independent, where I say dependent is what you want to predict, while independent is those things that you use in predicting the dependent. Then after you've done that first split, you need to split into training and testing. So this train test split is what you use to split your data into training and testing. Now, another significant, it looks very simple, but it's one of the most significant process of machine learning, and that is what we call model evaluation. Model evaluation is where you check how well is my machine learning model predicting. How well is he able to predict something? What is his accuracy? That is the last step before you deploy. That's the last step you do before you deploy. You need to evaluate how well is the machine learning model performing. So in order for you to check, you will use for a regression task that day I mentioned some evaluation techniques. I said we use mean square error, mean absolute error, R square value. Now, R square value is the one that we measure using this R2 score. Whereas mean squared error, we use this. If it's a root mean square error, we square this mean square error. Then we have mean absolute error. There are many, but it's not a must that you must use all. When you are measuring, you are trying to check how well your machine learning model is predicting. You can use two. At times you can use one. It depends on you who is doing the work, or it depends on what you are being asked to use. So for this case, I'm just going to use R square value and mean square error to check how well our developed model is predicting. So I've imported the libraries. The next step is for me to upload my data. And remember, I told you since it's a Google Colab environment, in order for you to upload your data, you must say from google.colab import files, and then you need to run this line also, file.upload. So the moment we run it, it will allow us to upload our data set. So I will go to the folder where the data set is. This should be the data. Okay, our data set has been uploaded. So if we check by the side here, we'll see this is the data set. So I said once the data set has been uploaded, you click here, go to copy path, and then you paste here. So it's the same thing already. I'm just re-showing the steps afresh. So we run. Now our data set has been uploaded. The next thing is your statistical exploration. You check the head of the data set. Next, we check detail. So I'll be skipping some of these steps because this is not our focus for today. So I'll just run it so that we'll get to what we'll be doing today. So your basic data preprocessing, which are things I've explained you. The data, if there's missing value, you remove them. You can do feature engineering where you add more data to your data set. That day I taught you how to do feature engineering. And then we create new columns. I want to get to the end so we can start properly. We also did some visualization, which I said they are all data exploration. Okay, I think I've come to the end. Okay, so today, what we'll be looking at today is how to build a machine learning model. So to build your machine learning model, first of all, let me print out our data set. Let's print the head of the data to see what is in the data. Now, I said we want to build a machine learning model that will predict the shoe size of a person. So put that at the back of your mind. What you are trying to predict is shoe size. It means shoe size is your dependent variable. That's what it means. If they say build a machine learning model to predict something, it means shoe size is your dependent variable. So this is the column for shoe size. This size. That is what you are trying to predict. So you've already done your other basic step of importing the data, performing data exploration, performing data preprocessing, where we added new columns, we drop missing values. All those things are what we call data preprocessing. Now, the next step we'll be going to is data splitting. Data splitting. So in data splitting now, what we'll be doing is we need to split our data into dependent variable and independent variable. And if you recall in our last class, I said dependent variable is what you want to predict, while independent are the one that you use to predict the dependent. And I said all independent variables, you call them x, whereas your dependent variable, what you are trying to predict, you call it y. Now, how do you separate them? Now look at your data set. Remember, I told you in your data set, anything that you don't want in the data set, you use drop to remove that thing. If you check in this data set, all these things are all these columns are our independent variables, except this size. This size is not our independent variable. So how do you do it? In order for you to do it, to put it in your independent variable, you say data dot drop, then you put the name of that column you want to drop because you don't need it. Size is our independent variable and we don't need it. So in our dot drop, we are going to put size and then comma, you always give your axis. Our axis is 1. So it means we are going to remove this size from the data set. Any other thing that is left after we remove size is our independent variable. Then when you come to the dependent variable, size is your dependent variable. So you pass it like this. Size is your dependent. So let's check and see. If I print X now, you see that size is not there in the data set. Can you see? We have age, we have height, we have gender, we have size HT, we have size status, but we don't have size. It means we've removed size. Size is not inside our independent variable. Why? Because it is our dependent variable. So let's print X. You see that all those sizes that were initially here, these 40, 39, 39, 40, you see they will be the ones. Can you see them? They are the ones that are in your Y. So this is how you split your data. So that data that you're trying to predict, pass it to your Y. Give it its name here. Whereas the one that you don't need, the one you're trying to predict, remove it from the original data set and then pass it to Y. Now, after that, machine learning model doesn't understand a table like this. It doesn't understand a table like this. It only understands list of numbers. So the moment you split your data into dependent and independent variable, always add dot values at the end. Always add dot values so that the numbers will be converted to a list or a numpy. We call it numpy array or we say list. Now if I should print X, you see that, can you see the form of X has changed? Can you see? It has converted all the data that are in that table to a numpy array. So a machine learning model understands this one. You might see that it doesn't look understandable, but the machine learning model, this is what it understands better than this one that you understand. So if we check the Y also, you see the same thing. You can see the Y too has been converted from a table. It is now an array. So your data is ready for machine learning model development now. Now, in order for you to develop a machine learning model, you've done your first split. Now, remember I said we have two types of split. The first split is to separate dependent and independent. The second split is to separate into training and testing. So, in order for you to separate into training and testing, you always separate your data into 4 things. So, please, the way I'm going to write it, that's how you always write it anytime you are doing. You always start with separating the X first. You call it X train, comma, X test. Because it will be splitted into training and testing. The same thing again, Y train, comma, Y test. Now equal to, you now call that train test split that I told you of. Now the train test split, the moment you give him your X and your Y, he knows how to split it. So you see that I wrote 4 things, you'll be saying, when we are doing variables, only one thing we usually give. Here you give the 4. The train test split, we split it and give these 4 people. So now after doing that, what are you going to give your train test split? Remember, we started with X train, X test. So you give X first. You say, I want you to split X for training and for testing. After that, comma, then Y. You are telling me after you are done splitting X, split Y too to training and testing. That is what it implies. Now, after that, the last thing you have to give is test size. Now, we don't give train size. We give test size. The moment you give him the test size, it automatically knows the train size. Now, remember, I told you a whole data set is 100%. I say at times you can split 80% for training, 20% for testing, or 70% for training, 30% for testing. Now, in the machine learning model, it doesn't understand percent. It only understands between 0 and 1. 0 means 0%, 1 means 100%. So, me, I'm going to split my data into my test size. I'll give him 1.1. Dot 1 means 10%. Use it for testing. Now, since I've given it dot one as the test size, it automatically knows that 90%, that is 0.9, is for training. If I should change here to dot two, it means it knows that my test size is 20%, my training size is 80%. If I should change it to dot three, it knows that my test size is 30%, my train size is 70%. So this should be the highest of your test size. Don't give test size of dot four, dot five. No, it will lead to overfitting. It will make the machine learning model not to learn very well. So always give a small test size. So for this case, I'll maintain it with dot two. So I'm giving it 80% for training, 20% for testing. So the moment I run it, it's going to split my data. Yeah, it has splitted my data for training and for testing. So X has been divided into two, X train and X test. Y has also been divided into two, Y train and Y test. Now let's start building the machine learning model. How do you build? Now remember, we've imported the machine learning model we are going to use here. We call the name linear regression. That is the model we are trying to build, because you can build a machine learning model using different algorithms. Now, the first thing you need to do is to initialize your linear model. Okay, I might give it a name. So I will call it linear, for instance, because if you are using another different algorithm, you must give it a different name. So you can't give them the same name. So this one, let me call it linear. Now you initialize that model regression. You initialize. Let's run. Now I've initialized. Now if I write linear, you will see that linear regression will appear. Can you see? I've initialized my model. Now, after initializing your model, you train it. How do you train? In order for you to train a machine learning model, you write the name of the model first, and then you put dot fit. Dot fit means I want you to train. And then you give him the X data and the Y data for training so that he can train and learn. So inside the bracket, I'll pass train, comma, Y train, and then I run. Now it is the training that takes longer time. It depends on the algorithm you are using, and it depends on the size of the data. Our machine learning model has finished training. The next thing you have to do now is to test the machine learning model. So in order for it to test, he's going to do a prediction on that. Remember, we split our data. X train, X test, Y train, Y test. So this X train and Y train are used for training. But if you want to test, you always give him this X test and then you hide this Y test from him not to see. Then after it has done his prediction for the X test, you now compare what he predicted with this actual Y test. That is what we tell you how well the machine learning model is predicting. So remember here, we've trained it. Now let's test. In order for us to test, we are going to say linear, that's the name of our model, dot predict. Then in bracket, you give him that X test. Now, what does that mean? It means I want you to make a prediction for X test. Now, let's print Y pred and see the values that it predicted. Now, these are the values it predicted. But remember, if you check all our sizes are in integer. There is none that is decimal. Whereas our prediction is coming as decimal. You can change that. In order for you to change that, remember I told you can change something to as type. When we're doing pre-processing, I told you anything you want to change to integer, you can add this dot as type int. If you want it to be decimal, you say dot as type float. So let's run it Now let's run. Now you can see this is the prediction. Now let's check. Now you can use that Y test now to compare. Y test to compare. Now let's see how well. Now you can see the first prediction here. The first shoe size here was 36. Our machine learning model was close. It predicted 35. The second one was 43. It predicted correctly 43. The next one 39. It predicted correctly 39. 40, 40, 41, 41, 41, 41, 45, 46. You see, at least the machine learning model is trying in terms of doing the correct prediction. So how do you check the overall performance now? In order for you to check the overall performance, this is what you say. You say print now, or there's no need for print since you are doing it in a Google Colab. You say R2 score. R2 score means compare. You compare it. Now, what are you comparing? You compare Y-pred, that is the prediction of the machine learning model, Y-test, that is the actual values that you hid from the machine learning model. So let's run it and see. Now, it has 0.96. This 0.96 means 96% accuracy. It means this machine learning model that we develop has an accuracy score of 96%. It means it is predicting very well. It has an excellent performance in terms of prediction. So this is how you build a machine learning model. There's nothing complex. You have finished building your machine learning model. Now, let me show you a practical illustration of how you can test. Let me bring out our data and then I'll copy out some data. Remember, our independent variables are these: height, gender, shoe, HT, and then size status. Now, let's hide. I'm going to hide this 39 from. Let me reduce this size. Let me even make it 3. I want to see few data because I want us to be looking up and down. Okay. Now this is the data. I want to predict this shoe size here. I want to predict it. So I'm going to hide this 39 from my machine learning model. I'll give him the height. I'll give him the gender. I'll give him this one. I'll give him this one. And I want it to predict. So let's do that. First of all, let me call this one testing data. For instance, my testing data should, let's do it straight. We'll say linear. The name of our model is linear. So we'll say linear.predict. Anytime you want it to predict something, you say .predict. Now, and if you another thing is, if you are trying to test it to do prediction, always do 2 brackets. That is, if you are trying to give him a raw data, unlike your Y test. If you are doing Y test or X test, you put it direct. But if you are trying to give him raw data, always put 2 brackets because it's a NumPy array. It converts a list to a NumPy array. So NumPy array goes with 2 brackets. So let's see. We want to predict this 39 bar. So the first data is 171. 171. Separate it with comma. The next data is 2, comma. We are not giving him 39 because that is what we want to predict. The next one is 4.3. Don't know why this thing keeps popping up. 4.3. 4.384615, and then the last data is 1. So let's remember, always convert it to as type int, dot as type, except if the prediction you are doing is a decimal number. If it is a decimal number, don't convert. But because ours is not a decimal number, that's why we have to put this as type int. So let's run it. You can see the size was 39. You can see it's predicted correctly. So you can see that our machine learning model is working perfectly well with an accuracy score of 96%. Remember, I told you accuracy is from 0 to 1. So 0.96 means 96%. If it's 0.75, it means 75%, like that. Or you can say it has an accuracy of 96.53% or 54. It's still the same thing. So this is how you build a machine learning model. Now, let's try another model again and see. Let me say I want to use support vector machine. So I'll say from sklearn.svm import support vector regressor. Remember, it's regression we are doing. So I'll import SVR. I told you if it's classification, you import SVC. So let's call it SVM. Let's assume that's the name of my model. So first of all, initialize. After initializing, you train. So you say svm.fit. You pass your x train, comma y train. Now let me just do everything there. I will say my ypred should be equal to svm.predict x test, and then after that let me evaluate R2. So you can do everything on one line and then run it at once. R2 score of y pred, comma x and y test. So let's run and see the performance. Support vector machine is performing very bad. Why is it performing very bad? There are some machine learning models that are not suitable for a particular data. So if you say machine learning model is performing bad like this, it means is not suitable for that particular data. So that is why whenever you're trying to build a machine learning model, don't use just one. Use different models. After you finish, compare them. The one that is performing best is the one that you pick. So now I've just done two. From these two that I've done, I'm going to pick this one, this linear model, because it gave me a 96% accuracy. This one is giving me negative. It means its accuracy is not even up to 0%. It has a very poor performance. It means the model is not suitable for the data set I'm working with. So this is how you build a machine learning model for your work. So with this, I'm stopping here for today. I've come to the end of today's class. So I'm giving rooms for question now. If you need clarification on anything, you can ask. Room for questions?
I don't have any question really, but I kind of understand the class, so it is straightforward now.
All right. Any other person? Or me, I should ask, but
Yeah, man, no ask question now. No ask question.
you know, Max. All right.
No ask question.
All right. Okay, rules for questions you have. Is there any questions, sir? It's as if you want to...
It's very clear, sir.
Okay, very clever. It's just assignment you are waiting for now, but
Just give us assignment.
Yes, sir.
all right, sir, no problem. All right, with this, I've come to the end of today's class. So, before tomorrow, I'll look for a simple data set similar to what we've done, and then I will give you to build a machine learning model of your own, machine learning model of your choice. Now, you can make reference to that slide I gave you. You will see all the regression models I put there, so you can import any one of your choice and use. However, don't use one. Compare them plenty first, and then see the one that is performing better before you delete it. Because like this support vector machine, I can delete it because it's not performing well. I've checked and verified. So you can do like that, compare them, different ones. The ones that are not performing well, you delete. But the procedure are the same. The procedures are the same. The ones that are not performing well, you delete, and then leave the ones that are performing well. Is there any question? It's as if someone wanted to talk.
No, sorry.
All right. Okay.
Thank you, sir. Thank you, sir.
In absence of... Okay. Mr. Owen, your hand is up.
Thank you, sir. I just want to appreciate. Yes.
All right.
Thank you, sir.
So
thank you.
We'll stop here for today. So
Thank you very
guys.
Dami, how far now?
Fine, sir.
How the cool weather for us? Me and Emma.